Now, earlier we had this buzzword called SaaS.
Yeah.
Now, the new buzzword is AI as a service.
Yeah.
But when you come to AI as a service, you need several tools and techniques to manage the AI workload.
Yeah. Yeah.
So, how is Vigyanlabs addressing this particular problem?
So if you look at today AI, right, AML, there are two parts, right? The traditional ML workloads, right? AML workloads, traditional ML models, right? You create mathematical models, you build one. The new gen is the Gen AI, right? You can see two different things, right? AML, you have traditional AML models, you need tools, right? The standard tools. We ourselves use it. We have built our what we call our AI engine as PowerMind. We use our AI engine for running our workloads. We have created a PowerMind Studio, which creates quite a few ML models, right? Off the shelf ML models, which you also built and using. We may expose that people use ML models. So many of the traditional models, ML models, everything does not require please understand, every AI model does not require a GPU. There are a lot of models which, traditional ML models, which can run on a computer infrastructure. It has a good computer infrastructure, it can run there.
Okay.
So ML models are there. Next is Gen AI, right? Gen AI LLMs are there. So you see, there's no one big LLM which can solve every problem.
Correct.
What we feel is our opinion is that you need a wide variety of ML models. There are quite a few open source ML models, could be custom built by enterprises. So you need, as example, a generic chatbot, you need an ML model. You need a OCR, ML model OCR, you need a speech to text recognition. You need to put them together, agentic AI to weave them all them together to automate the
Support all native language.
So basically we create a PowerMind Studio, pulling in a couple of open source models, couple of our own models, put together, weaved into Studio, where people can drag and drop, create AML applications.
Okay. So when you say actually create AI applications or create infrastructure for AI, there are people out there who really don't know how to actually what kind of configurations they need to buy or procure, because they would end up burning a lot of money.
Yeah.
So how would the Vigyanlabs assist those people so that their AI workload can also be handled, and at the same time their pockets are not deeply burnt?
See, basically, you should understand, majority of the organizations will end up doing inference, not training.
Correct.
Okay.
Correct.
So let's not be confused, So somebody is building a 200,000 GPU based model. Do you need that? No. Just few people will create models.
Correct.
And the majority, I would say 99%, 99.99% people will end up doing inferencing. You may probably use a RAG chatbot to add extra, additional layers of complexity to that model. And so what we are trying to talk to institutions and enterprises, understand their use cases. See, basically, it's not about throwing GPU and LLMs. Understanding specific users and solving a problem.
Correct.
That's what we are trying to talk to every customer and try find out what is the use case relevant to them.
Okay.
Once you know the use case, and then you actually size the infrastructure for them.
So it is a customized approach what you take for each one of them, and do the server sizing accordingly.
Yeah.
And help them with what is actually required for them.
Yes.
And scale as and when required.
Yes. Yeah.
Okay. Going back in time, in 2010 when you started building Aadhaar, there was no GPU.
Yeah.
So using only CPU, you have done a wonderful job.
Yeah.
So with that in mind, and if GPU is there today, what is the big difference that would you see, and how can such kind of applications be developed now?
See, basically, many of things, like if you look at it, biometric, right? Biometric deduplication is a parallel processing job. Massive parallel processing, right? Massive processing. Because what are you doing today? Let us look at a biometric, right? You have 10 fingers, face, and iris, 2 iris, right? You have 10 plus 2 plus 1, 13 parameters, right? 13, at least minimum 13 parameters. Plus, of course, your other I would say, demographic data is a name, age, date of birth, parents, name, there are other data. Basically, every person's data, you're going to compare against everybody else. So it's an n square, sort of n square computation, right?
So it's a billion comparison.
So each person, let's say 11th person, right? 11th, let's say I have data of 10 people. I have the 11th data to be compared against 10 people. As you please understand that each of the 10 people, we have 13 parameters.
Correct.
You already have 130 parameters.
Correct.
Now we have to compare the new 13 parameters against the 130 parameters. Just imagine how many comparisons we need, right? In a massive amount of comparison. Okay, like this. So one is you can do sequentially. One after that,
it will take a lot of time.
And for one person, assume you want to enroll a lot of people, millions of people, right? You need a parallel computing infrastructure, right? Yeah. Infrastructure, so you can do it in parallel. So I think long back, 15, 20 years back, probably we had a 10 core process, right? 10 core process. You had to put, 10 core or 20 core process. Late, if you look at 2008, 10, we had 6 core, 8 core, 10 core process. Over time, the computing capacity improved. So we need thousands of cores to do in parallel processing, right?
Correct.
Today, what you can do is thousands of cores of parallel processing. A small single GPU can do, right? Today, you have GPUs with 20,000 cores, 40,000 cores, a single. So today, what GPU has, changed the paradigm of HPC. So people, use massive amount because a single server, historically give less than a or maybe 0.1 or 0.2 teraflops.
Correct.
When you get a teraflop, you put about 10 servers. And put 100 teraflops, you did a massive HPC, right?
Correct.
HPC infrastructure. Now, what you require, I just saw some institution wanting a petaflop of, HPC computation.
Okay.
So, based on legacy architecture.
Okay.
So, we can provide today a petaflop of computing HPC like infrastructure in a box, small box.
In a box, okay.
So, which means that you need to relook at your HPC workloads.
And relook into the architecture as well.
Architecture, it's not re-architect. If you re-architect the HPC workloads, it requires parallelism.
Okay.
Can do with a very, very minimal infrastructure.
Okay.
And very small footprint at much significantly lower cost and speed, right?
So this is a classical example of parallel computing, what you are saying.
So but AI actually enabled parallel computing to go at scale, massive scale and speed. So what HPC people used to do a batch jobs, right? Batch jobs. Even in a deduplication, people used to do batch jobs.
Correct.
What we used to do in batch jobs can be with a massive parallel infrastructure from AI, the GPUs you can do in real time.
Correct.
So today real time HPC is possible, right?
Real time.
Many of them. We just need a fairly reasonable number of AI computing infrastructure, right?
So people out there should really look out what kind of problems they are solving and the complexity of the problem.
Yeah.
Comparative to other, then accordingly size is what you say.
Just not just look at any parallel weather forecasting. Any look at any parallel computing HPC infrastructure. I think we start re-looking at the HPC. We need hundreds of servers, massive infrastructure to do a computation. You need to re-look at your applications, right? Rewrite the application. You have to reimagine the applications for the GPUs.
For the GPUs.
You can shrink your computing infrastructure drastically, and you can achieve results much faster.
So the first and foremost thing for the young kids over there.
Yeah.
If they want to develop anything related to AI, they need to understand the power of these CPUs and GPUs first.
Yeah.
And accordingly work back and look at what kind of computation they would really need.
Yes.
So this would help in cooling the earth and not overheating it.
Yeah.
Okay. When you're doing all these things and when you look from a context of India, we are good at using tools and technology.
Yeah.
But very rarely we contribute to open source technology.
Yeah.
So what is your take on this? Because as we go forward, open source technology, adopting open source technology is the way forward, both from a strategic point of view and as well as from an economic point of view.
Yeah.
So what would you say here?
I think, open source is a great thing happened, right? It is sort of democratized computing, right? Everybody can afford it, right? With Linux available. We are all having the benefits of open source today, right? Every phone, you have the smartphones, right? What is smartphone? What is Android? Underneath Android is open source Linux, right?
Correct.
Linux. So Linux is sort of, although Linux didn't enter the mainstream, the desktop continued to win Windows. Quietly it has entered your homes, right? Every desktop, every phone, your watch, open source, based on open source technology. So the industry has leveraged open source to make the computing more affordable. And India, unfortunately, so far we have been a consumer's open source. It's a better time with the billions of people, right? We start contributing back. How do you make the open source in more, how do you make more people adapt open source? It's contribute back, right? There's so much problem to be solved in the AI world. I think we need to create more and more communities of open source. Start with academic institutions and industry. Start contributing back, right?
Contributing back.
And we
Build the community.
Build a community. We need to build a larger community of open source tools. There's a whole lot of open source tools and technology we need.